Hey everybody, we're going to go over operations with matrices today, which is pretty fun. And let's go over some important vocabulary. Scalar multiple. Scalar multiple has to deal with a constant value we call C, and a matrix, we'll call it A. So matrix can be denoted by a capital letter. And let's just say we've got these terms L, M, N, and X, Y, Z. And if I multiply the constant times matrix A, we'll get a matrix that looks like C times L, C times M, C times N, C times X, C times Y, C times Z. A zero matrix is simply a matrix with only zeros in it. Okay, it could be any shape. An additive identity matrix, just like in order to add a number to another number, to keep it the same, we add 0. When you add we call this, the zero matrix is called like just a big, thick, round 0. That's the zero matrix. So if I add matrix A plus matrix 0, we get back matrix A because that's the additive identity. When we're talking about matrix multiplication, there's a couple of things that are really important. If the columns of matrix A equal the rows of matrix B, then matrix A times matrix B can exist. Okay? And the identity matrix of dimensions n times n, which is a square matrix where the rows and columns are the same. An identity matrix looks just like a reduced row echelon matrix, but it's square. If I multiply, we call this the identity matrix. Any matrix times the identity matrix will get the same matrix back. All right, so name 3 ways that a matrix can be represented. So there can be an uppercase letter that represents the matrix. It could be matrix A, matrix B, matrix C, and so on. You could also have it represented as an element of a matrix enclosed in brackets, like such as some term and the row by the column measurement, or simply the rectangular array of numbers that we've been using. And then 2 matrices are equal if they have the same dimension and their corresponding entries are equal. So for example, if you've got these matrices and they're equal to each other, this value here will equal this value, and so on, right? So corresponding matrices are equal like that. So to add 2 matrices of the same dimension, you simply add the corresponding entries. And then to multiply a matrix A by a scalar or constant C, we multiply each entry by the value of C. So for example, if I've got these two matrices A and B, A is a 2 by 2 matrix and B is also a 2 by 2 matrix. In order to add or subtract matrices, they have to be the same dimensions. So if I wanted to find matrix A plus matrix B, I'm going to write, here's matrix A. So I'm just rewriting it and adding it to matrix B. And I'm going to add the corresponding values and put it back in the corresponding spot. So 2 plus a negative 1 would go right here. So 2 plus negative 1 is 1. 5 plus 4 would go right here. 9. Negative 3 plus 2 goes right here, which is negative 1. And lastly, 1 plus negative 5 would go right there. It would be negative 4. And then if I wanted to do the operation of negative 2 times the matrix B, I'm literally going to say negative 2 times matrix B is 1, 9, negative 1, negative 4. You're going to get the same size matrix back. So remember, it's a 2 by 2. And we know here, well, we go negative 2 times 1 in the first spot. And then you would go negative 2 times 9. And then you would go negative 2 times negative 1. And then lastly, negative 2 times negative 4. And then to simplify, we get negative 2, negative 18, positive 2, and positive 8. Okay, so let's talk about this one. So we're not going to talk about all these properties. We don't need those today. So when we're multiplying a matrix, the definition of matrix multiplication indicates a row by column multiplication, where the entry in a certain row and a certain column is attained by multiplying the entries into the ith row by the corresponding entries in the jth column, and then you add. And I'm going to show you how to do that right now. Okay? So, for example, if matrix A is a 3 by 5 matrix, and matrix B is a 6 by 3 matrix. Find the dimensions, if possible, of the product A times B. So before we even look to see what the matrix is, we need to see if it's possible, and we look at its dimensions. So if matrix A is a 3 by 5 matrix, and matrix B is a 6 by 3. To find if matrix A times B will work, here's what you do. You list the dimensions next to each other in the order that you're multiplying. If the numbers, the column of the first matrix equals the row of the second matrix, it will work. Are these the same number? The answer is no. So this would be not possible to multiply matrix A times matrix B. Okay, that was for part A. Part B says, well, is matrix B times matrix A possible? Let's see. Remember, matrix B is a 6 by 3, and matrix A is a 3 by 5. does this row, excuse me, does this column equal this row? The answer is yes. So this is possible. Okay, so if it's possible, then you would go to set up that multiplication. So now let's talk about how to set up the multiplication, okay? It says find the product matrix A times matrix B if matrix A equals this, we call this a 2 by 3, right? Because we have 1, 2 rows and 1, 2, 3 columns. And this is a 1, 2, 3 rows by 1 column. So is this possible? Do these numbers match? They do. So it is possible, and this is how you would set it up. If it's possible, here's what the end matrix is going to look like. It's going to take these dimensions on. So matrix A times matrix B is going to be a 2 by 1 matrix. So that's what you're going to set up first. You're going to set up give yourself a lot of space, but it's going to be 2 rows across and 1 column. So we call this row 1, row 2, column 1. And we call this row 2, row 1, column 1. So we're going to, number 1, find the dimensions of the product matrix, and you're going to label the first matrix as the row matrix, and you're going to label the second part of the product as your columns matrix, as well as your product matrix. Okay, so we did that here. We labeled the first, I messed up on that. This is not row 2. So this would be row 1, row 2. And this is the first matrix we're multiplying. And this is the column 1 matrix. And then in order to find what goes where in the product matrix, we know row 1 times column 1 would be this entry. Row 2 times column 1 would be this entry to find it. So here we go. We're going to take row 1 and multiply it by column 1. And here's how we do it. Okay, so 2 times 0 plus negative 1 times negative 2 plus 7 times 3. Okay, and we'll simplify that down, but we're going to do the next one. So now we're going to say if this is row 2 times column 1, we're going to go row 2 times column 1. So here we go. 0 times 0 plus 6 times negative 2 plus negative 3 times 3. Okay, so now we're done setting it up, and now we're going to simplify those numbers. So I know these are my entries. 2 times 0 is 0 plus positive 2 plus 21. 0, negative 12, negative 9. And we simplify that to 23 and negative 21. And this is our product of matrix A times matrix B. Hope that makes sense. If it didn't, go back and re-watch it. Okay. So if an n by n matrix, remember n by n just means that they have the same dimensions. The identity matrix has the property if matrix A is multiplied by the identity matrix, it equals matrix A. And the identity times matrix A also equals matrix A. So it can go either way, okay? The matrix multiplication can be used to represent a system of linear equations, and this is what this means. So we're going to be able to write, okay, instead of this whole array, we're going to describe this as a matrix equation. So we see here that in the front we see all of these A's. These A's have those dimensions. So like this dimension right here is matrix entry A, row 1, column 1, matrix entry A, row 2, column 1, matrix entry A, row 3, column 1. So we can see that all of these are entries from matrix A from the different columns. So that comes from matrix A. All of these entries are the column values from matrix X. And we see that they equal the values from matrix B. So if we consider the following system of linear equations, write this as a matrix equation, A times X equals B. So remember, the number in front is going to be the A matrix. So we've got 2, there's this -1, 3, there's a 1 in front of the x1, this is a -3. So basically, the coefficients in this case are going to be the A matrix. Sorry, I'm filming in my car just turned off. Here's our X matrix here. You can see it here. And then we've got our constant or answer matrix. I should use a different color for that, huh? So we've got matrix A times matrix X equals matrix B. So let's spell that out. Okay, what is matrix A? Matrix A is 2, -1, 3. 1, there's no X term here, so that's 0. So 1, 0, -3, -1, 4, 2. Oops. And then the X matrix is going to be x1, x2, x3, and so on. And we see x1, x1, x1 is here, so we know that's a column. x1, x2, x3. And then our last one is our B matrix, which is also a column matrix, -11, -1, and 2. And we can see here and verify that it is the right size, because if this is a 3 by 3 matrix and this is a 3 by 1 matrix, these will match. So this is the dimensions of the final matrix, which is 3 by 1, which is correct. Okay. So for this one, now it says, okay, whoops, sorry guys. Now that I've written the matrix, it says use the elimination on the augmented matrix to solve for X. So let's write the augmented matrix, okay? And instead of doing it by hand, I'm going to show you how to do it on the calculator, which is super, super easy. So here's our augmented matrix. 2, -1, 3, 1, 0, -3, -1, 4, 2, and our constant is -11, -1, 2. So I'm going to show you how to do this in a calculator. I'm going to be using the Desmos matrix calculator. Literally, you just type in Google Desmos matrix and it'll pull it up for you. Let me show you what it looks like. This is what the Desmos matrix calculator looks like. If you want the address, it's just www.desmos.com/matrix. Okay, so this is what you're going to look like. And first you're going to click this blue button, new matrix. And down here, see where it says edit matrix A? We're going to type in the dimensions of rows by columns. Well, our augmented matrix was 3 rows and 4 columns. And what's cool about this is if you realize you inputted the wrong dimensions, you can always change it. And now you're going to go one by one and type in the values of the rows and columns. So on the top row, it's 2, going to click the next one, -1, click the next one, 3, click the next one, -11. And you're going to do that for every single one. Okay, instead of wasting your time showing you how to click every single number, I've already put it in right here in this one. And then, so there's our matrix A in our augmented matrix form, which is exactly what we want. In our second line of our calculator, you're going to tell it to put this matrix in reduced row echelon form. So do you see this button down here at the left-hand corner, RREF? So it's saying, okay, I'll take reduced row echelon form of what? And you're going to look at the names of these matrices are these big capital letters. Our matrix was named matrix A, so we're going to click matrix A. And boom, it did it automatically for you. It's right here. And this is the reduced row echelon form, which gives you the values of our solutions. So we're going to take that answer back to our problem. And when we used reduced row echelon form in the Desmos matrix, we got 1, 0, 0, -4, 0, 1, 0, 0, 0, 0, 1, -1. And that tells me my answers are x1 equals -4, x2 equals 0, and x3 equals -1. Okay? And so that's how you use the calculator for that. Super fun, super easy. We'll talk more about it. I'll see you guys later.